My name is Stephan Brönniman, I'm from Switzerland. I'm visiting Museum WF here for 2 days to attend a meeting. It's the ERA Clim 2 kickoff meeting. I'm excited about a new project that we're going to have here, and this is about producing a reanalysis, global reanalysis, and our part here is to provide historical observations for doing this reanalysis, upper air data, also surface data for making a global three-dimensional reanalysis data product. This data product, we hope, will be widely used in applications, including applications of severe weather, applications of climatological aspects, application, of course, of weather research, atmospheric sciences, and all sorts of impacts that can be linked to the atmosphere and also to the ocean. Okay, so for a long time we have been working on historical data. We try to compile as much historical information about the atmosphere as possible and try to piece together this information, which is not so easy because a lot of the data and also expertise on this historical data is lost, and we have to find these data, we have to inventorize all the existing data sources, we have to go to the archives, photograph these old historical sheets of data, it's all on paper, and then we have to get these data back to us, digitize these data using different methods, mostly keying, also in some cases speech recognition or optical character recognition, and all sorts of quality checks, and there are errors everywhere. In each step there are errors. We have to be aware that we're all humans also, so errors happen. And in the end we hope to deliver a product, a compilation of historical, especially upper air data, so weather balloons, kites, pilot balloons, aircraft, everything that goes up in the atmosphere, and to have as much information as possible about the three-dimensional structure of the atmosphere in the first half of the 20th century, when up to now not much information has been available. This information is really important to make a three-dimensional data set of the atmosphere, and we've been working on this for the past 10 or 15 years now, and we're excited to see it now bearing fruits and leading to a new data product that can help people. The use for this product, there are many possible uses of this product. So this can be atmospheric sciences, it can be research, but you also can downscale the product, so you can have regional information, even local information with a chain of models embedded. You can then use these data to drive an impact model, for instance a windstorm loss model, or a hydrological model to simulate flood events. We are not doing that, we just provide the data that would enable this sort of applications. To make an assessment of the link between extreme events and climate change, what is needed is long records, because extreme events are rare by definition, so we need long records that cover many extremes, and this is what the analysis should provide. We have a long record, we will have a 110-year record, we'll start in 1900, so we'll have many of these extreme events in our record, in our database, and we can study these more cases than previously possible.